More than 50 years ago, Apollo astronauts brought bags of moon dust back to Earth. In 2026, scientists looked at that old material with a new technique and found something the astronauts themselves could never have known. The scars preserved in lunar soil now place a limit on how much water late meteorite impacts could have delivered to Earth. Rocks collected before many scientists working today were even born are changing the story of where our water came from. And that leaves the obvious question. If late space delivery was not enough, where was the rest hiding? For a long time, the story was wonderfully simple. The young Earth formed close to the Sun, so it should have been hot and nearly dry. Then, icy asteroids and comets arrived from farther out, crashed into the planet, and delivered the water that eventually became the oceans. It is the kind of explanation that fits beautifully into one illustration. The problem is that the evidence started refusing to cooperate. The Apollo result does not mean asteroids played no role. Early asteroid impacts may have been extremely important. It means something narrower and more interesting. You cannot keep adding late meteorite impacts until they magically account for everything. And now, another NASA mission is looking even farther back. SphereX has mapped enormous regions of water ice attached to interstellar dust inside giant clouds where stars are born. These are the kinds of environments from which new stars, disks, asteroids, and planets eventually emerge. That is where the story becomes almost ridiculous in scale. Before there was an Atlantic Ocean, before there was North America, before there was Earth, there was already water ice in the raw material between stars. Not necessarily the exact molecule that will end up in your kitchen faucet billions of years later. Molecules break apart and reform. But some of the atoms and some of the chemical history behind that water can be older than the sun itself. So maybe we have been asking the question badly. Where did Earth get its water sounds as if there should be one address. There may not be one. Some ingredients may have been inherited from interstellar ice. Some may have been inside the material that built Earth. Asteroids probably delivered more. Comets likely contributed something. And the solar wind can help create water on mineral surfaces. Earth then lost some water, buried some of it, recycled some of it, and kept the rest moving for billions of years. The ocean may not have a single birthplace. It may have a criminal record with too many addresses. And once you allow material to move between worlds, another idea enters the room. What if some of it was sent deliberately? This is not an idea that began only with UFO forums. In 1973, Francis Crick and Leslie Orgel discussed what became known as directed panspermia. Crick was one of the scientists associated with discovering the structure of DNA, and Orgel worked on the chemistry of the origin of life. They were not saying that alien tankers carried the Pacific Ocean across the galaxy. That would be a terrible shipping business. The more economical idea is that a technological civilization could send microorganisms, spores, or biological material toward planets where those organisms might survive and eventually spread. The uncomfortable part is that nature already performs half of this trick. Meteorites contain organic molecules. Amino acids have been found in extraterrestrial material. Asteroids move carbon, minerals, and water through space, while violent impacts can blast rocks off one planet and send some of them toward another. Mars rocks have reached Earth naturally. So interplanetary delivery is not science fiction. The missing part is the sender. We have never found an ancient machine, an unmistakable artificial container, or a message saying that somebody planted life here. Nature already knows how to move the cargo. We have no evidence that anyone scheduled the shipment. That keeps directed panspermia in a strange position. It is not physically absurd, but it is also not demonstrated. A more extreme version says that life was not the only thing prepared. Maybe Earth itself was prepared. Look at what we have. Enough gravity to hold an atmosphere, temperatures that allow liquid water over huge areas, continents, oceans, carbon, minerals, sunlight, an active interior, a water cycle, wet periods, and dry periods. From inside the system, it can look suspiciously convenient. But there is a trap in that argument. Imagine waking up in a room with enough oxygen to breathe. You look around and announce that the oxygen proves the room was created specifically for you. Maybe it was. But if there had been no oxygen, you would not be standing there making the argument. We observe a planet compatible with observers from the surface of a planet, where observers manage to appear. That does not prove there was no design. It means habitability by itself is not a signature left by a designer. Still, water is a remarkably useful substance. It dissolves an enormous range of materials, carries salts and gases, transports nutrients, absorbs large amounts of heat without immediately changing temperature, and lets molecules move, collide, and react. Then there is the strange behavior of ice. Ordinary ice floats. That sounds like a fact too boring to deserve attention, until you imagine the opposite. If frozen water always sank, a lake could keep dropping newly formed ice toward the bottom. Over time, winter would become much more destructive for aquatic environments. Instead, floating ice can form an insulating lid, while liquid water survives below. Life got a roof instead of a concrete floor. But if water is so useful, Earth is not the only place that owns some. There is water on the moon. There is ice in comets. Mars has water ice. Europa, one of the moons of Jupiter, almost certainly hides a global, salty ocean below its frozen surface, and that ocean may contain more than twice the volume of all Earth oceans combined. NASA has already launched Europa Clipper toward it. The spacecraft is traveling through the solar system now and is scheduled to reach Jupiter in 2030. Its job is not to photograph alien fish. Its job is to determine whether Europa has conditions that could support life. That difference matters. An environment that can support life is not the same thing as an environment containing life. A furnished apartment and an occupied apartment are not the same thing. The furniture is not the tenant. Another ocean world makes the temptation even stronger. Enceladus, a small moon of Saturn, shoots material from its hidden ocean directly into space. Cassini flew through those plumes and found salts, organic compounds, and other chemistry associated with an ocean below the ice. Then researchers went back to the old Cassini data. In 2025, a new analysis identified additional organic compounds in fresh ice grains that had been ejected from the ocean and collected close to Enceladus. That is an extraordinary result, but it is not a dead alien, a cell, or proof that something is swimming below the ice. This distinction tends to die quickly online. A scientific paper says there are ingredients and potentially useful chemistry. A social media post says life is likely. A video says NASA knows there is life. Another video says NASA has been hiding the creatures for 30 years. By Friday, somebody has designed the creature. The actual situation is more interesting because the answer is still open. We keep finding water, organics, and energy in places that once looked completely hostile, yet the one thing people want most has not appeared. No confirmed extraterrestrial organism. Not yet. Earth itself gives us reasons not to underestimate weird habitats. Yellowstone is a beautiful example. Some of its hot springs look like places where ordinary life should file a formal complaint and leave. The water can be extremely hot, acidic, and loaded with chemicals coming from volcanic rocks and gases below ground. And microbes live there. Some use hydrogen as part of the chemistry that supplies their energy. That is why astrobiologists care about places like Yellowstone. It does not prove life exists in the ocean of Europa. It shows that the boundary between habitable and impossible can move when life finds a different chemical trick. Water is not just a place where life sits. Water is part of the machinery. On Earth, that machinery never stops. Water evaporates from the ocean, enters the atmosphere, falls as rain or snow, moves through soil, enters rivers, dissolves minerals, moves through plants and animals, sinks into rock, and sometimes returns from below through volcanic systems. The ocean is not a giant bucket. It is one moving part in a planetary machine. That helped inspire another idea that became famous far beyond geology and biology: the Gaia hypothesis. James Lovelock and Lynn Margulis developed versions of the idea that living organisms and the non-living environment influence one another over long periods. Life changes the atmosphere. Microbes alter chemical cycles. Plants affect carbon. Oceans move heat around the planet. In that scientific sense, the idea does not require Earth to think. It requires feedback. Then another version appeared in popular spirituality. Earth became literally alive. Oceans became blood. Rivers became veins. Clouds became breath. And water became a carrier not just of molecules, but of consciousness, intention, and memory. That is a much larger claim. Earth systems are connected, but planetary consciousness has not been demonstrated. We still argue about how consciousness emerges from the human brain. Jumping from there to the claim that an entire planet is conscious is not a small extra step. It is crossing the Grand Canyon, because the first sidewalk went well. Water memory produced an even more famous story. Masaru Emoto became known for photographs of ice crystals. He claimed that water exposed to positive words, beautiful music, or loving intention produced beautiful crystals, while water exposed to negative words supposedly produced ugly forms. It is an irresistible idea. Talk nicely to your water and it becomes beautiful. Insult it and it remembers. The problem begins when you ask how the photographs were selected. Freeze water and you can obtain many different crystal forms. If the person choosing the photographs knows which sample received the positive message, expectation can influence which crystals seem important. Nobody has to commit fraud. Human beings are perfectly capable of fooling themselves while trying very hard to be honest. That is why blind testing matters. If the observer does not know which sample should produce which result, expectation loses its steering wheel. Under controlled conditions, the dramatic Emoto effect has not become an established physical property of water. But the idea of water remembering something received a much more serious scientific challenge in the late 1980s. French immunologist Jacques Benveniste and his colleagues reported biological effects in solutions diluted so extremely that the original active substance should essentially have been gone. Think about what that means. The guest left the hotel, the room was cleaned, the sheets were replaced, but somebody claimed the guest could still turn on the television. If true, this would not have been a cute oddity. It would have forced scientists to rethink important parts of chemistry and biology. The result attracted enormous attention, and a team later examined the work under stricter blinded conditions. James Randi, a professional magician famous for investigating extraordinary claims, was part of the visiting group. That sounds strange until you remember what magicians are good at. They notice information leaking through tiny details. They notice when people can unconsciously communicate what they expect. They notice when an experiment has a hidden door. Once the samples were coded so the researchers did not know where the expected effect should be, the result failed to hold up. That does not automatically prove deliberate deception. Researchers can sincerely influence observations through expectation. Science created blind tests precisely because scientists are human. For some supporters, however, the failed replication became evidence of suppression. That creates a beautiful logical bunker. If the effect appears, the theory is correct. If the effect disappears, powerful people are hiding it. Nothing can get inside, including evidence. Water had already produced another scientific drama years earlier. Polywater. Researchers working with extremely narrow glass tubes reported a strange form of water that seemed more viscous and behaved differently from ordinary water. For a while, scientists wondered whether they had discovered a new stable arrangement of water. Then came the frightening thought. What if this new water could somehow convert normal water into itself? One contaminated drop reaches a river. The river changes. The ocean changes. No asteroid, no nuclear war, just very bad water. The ending was less cinematic. Contamination turned out to be the key. Material from glass, air, and the people handling the samples had altered what was being measured. Chemist Denis Rousseau famously compared evidence from polywater with human sweat. The revolutionary new liquid began looking suspiciously like a hygiene problem. Better controls killed the monster. But water really can contain information about its past, just not in the way Emoto imagined. The important word is deuterium. There is no reason to turn this into a chemistry lecture. Normal hydrogen has one proton. Deuterium has a proton and a neutron. That extra neutron makes enough of a difference that scientists can use the ratio between ordinary hydrogen and deuterium as a clue. Water formed or processed under different conditions can end up with different ratios. Evaporation can change them, escape to space can change them, and the location and temperature where material formed can leave a signal. That is a real kind of water memory. It does not remember your mood, it remembers chemistry. And that memory can survive long enough to help us investigate events billions of years old. Which is wonderfully ironic. People laughed at the phrase water memory. Then scientists built expensive instruments to read one. The language was just different. Deuterium also gives us heavy water. Heavy water looks almost exactly like ordinary water. The hydrogen has been replaced partly or fully by deuterium, which changes the mass and slightly changes chemical behavior. Small amounts of deuterium occur naturally in the water we drink, so a tiny amount of heavy water is not instant poison. The danger appears if a large fraction of the water in a living organism is replaced. Some biological processes slow down, and cell division can be disrupted. One neutron sounds like almost nothing. Biology disagrees. Heavy water also became part of one of the most dramatic real scientific stories of the Second World War. It could be used in certain nuclear reactor designs, and heavy water production in Norway became connected to German nuclear research and famous sabotage operations. That history was secret enough to generate a second history, made of rumors about hidden biological experiments, unknown weapons, and mysterious effects. Evidence for those additions is far weaker than the actual wartime story. Reality had already done most of the work. Conspiracy only added extra furniture. The modern American wellness market has its own descendants of old water legends. Living water, structured water, charged water, alkaline water promoted as if changing one property of a drink gives it a medical degree. Some treatments really do change measurable properties. Mineral content can change, acidity can change, dissolved gases can change. That does not automatically create a universal therapy. A human body is not a swimming pool that needs the pH adjusted before the weekend. For thousands of years, people in many cultures believed some waters healed and others harmed. That basic observation was not stupid. Different sources really can contain different minerals, microbes, toxins, and dissolved gases. The problem begins when a real difference becomes permission to invent any effect we want. Water does not need invented powers. Its actual behavior is strange enough. We learn three familiar forms at school: liquid water, vapor, and ice. Under different pressures, ice can form many different structures. Inside large, icy moons, some forms may exist because pressure is enormous, not simply because temperature is low. At still more extreme conditions, water can enter states that would look completely alien in your freezer. We do not need a catalog of every ice phase. The point is simpler. The word water sounds like the name of one easy substance. It is not. There is another problem with the slogan that water means life. Life as we know it absolutely depends on water, but water can also break chemical bonds. That matters when you are trying to build long biological molecules from smaller pieces. Water helps molecules move and meet. Then, under some conditions, it helps tear their relationships apart. It hosts the wedding and files the divorce papers. That is one reason some origin of life research pays attention to environments that repeatedly get wet and dry. Imagine a shallow pool. Water collects chemicals. Then the pool begins to dry. The same ingredients become concentrated in a smaller space, and molecules that were spread far apart suddenly meet much more often. Then water returns, and the products are moved somewhere else. Wet, dry, concentrate, dilute, repeat. Life may not have needed a giant permanent ocean as its first laboratory. It may have needed water that occasionally knew when to leave. Yellowstone gives us a modern reminder of the broader principle. Water and rock chemistry can supply energy to organisms in places that look hostile. Hydrothermal environments in the ocean are another major candidate in origin of life research. No single setting has won the case. The first life may have started in shallow, wet, and dry environments, or it may have involved hydrothermal systems. Different stages could even have happened in different places. Again, the same problem appears. We want one birthplace. Nature keeps handing us a network. And even if you solve the question of how Earth got water, you have solved only half the mystery. You still have to keep it. Mars is the warning. The planet once had rivers and lakes, and its surface preserves channels and sediments made by moving water. Today, Mars is a cold desert. Some water survives as ice and underground material, but a large part of the old surface water story is gone. NASA MAVEN mission has been studying how Mars loses atmospheric material to space. Scientists have measured hydrogen escape, and MAVEN has also observed processes capable of knocking atmospheric particles away from the planet. The technical names matter to specialists, but the basic image is easy. Mars was robbed atom by atom. Sunlight can break water molecules apart, and light hydrogen can escape more easily than heavier forms. There was no hole in the side of the planet with an ocean pouring through it. Give a small leak billions of years, and it stops being small. That is also why deuterium matters. When lighter hydrogen escapes more easily, what remains becomes relatively richer in heavy hydrogen. The isotope ratio becomes evidence of loss. The water carries the scar left by missing water. Venus may represent another route to disaster. There is still debate over how much surface water ancient Venus had and for how long, but some models allow a much wetter early world. Then the greenhouse effect becomes dangerous. More heat means more evaporation, and water vapor itself is a powerful greenhouse gas. More vapor can trap more heat, which puts still more water into the atmosphere. High above the surface, sunlight can break the molecules apart and hydrogen can escape. A planet can lose water without anybody taking it. It cooks the water, dismantles it, then lets part of it leave. Put Mars and Venus next to Earth and the question changes. Why did Earth get water begins to sound incomplete? Why is so much of it still here? Earth has been hit by enormous objects. Its atmosphere has changed. Its surface has been recycled. The sun was different in the past. Volcanoes have rebuilt landscapes, continents have moved, ice sheets have covered huge regions, and yet an open ocean still touches the atmosphere and continents after more than 4 billion years. Maybe receiving water was not the miracle. Maybe keeping it was. Earth mass helped. Distance from the sun helped. The atmosphere helped. The way the planet cycles material between the surface and interior helped. The moon may also contribute to the long-term behavior of Earth rotation and axial stability, although it would be far too simple to call it the single guardian of the oceans. There is no lone hero. The ocean survived because several pieces of the system happened to work together for a very long time. And a surprising amount of the water story is not visible at the surface at all. There is water in Earth rock. As oceanic plates descend into the planet, minerals carry hydrogen downward. Hundreds of miles beneath our feet, minerals in the mantle transition zone can store hydrogen inside their crystal structures. This does not mean there is a giant underground Atlantic Ocean sloshing around below Kansas. You cannot drill down and find a beach. The water components are bound into minerals. A rock can look completely dry while chemically carrying the equivalent ingredients of water. At those depths, water stops looking wet. That is the part worth remembering. Earth can hide enormous amounts of the water story inside material that does not look like water at all, and the story may go deeper, all the way to the core. In 2026, new high-pressure experiments produced a remarkable estimate. Earth core could contain a very large amount of hydrogen, perhaps an amount equivalent to several oceans, with the upper estimates reaching many tens of present surface oceans. That does not mean there are dozens of liquid oceans inside the core. There are no waves around the inner core, no whales, and no secret submarine base. The estimate concerns hydrogen dissolved or trapped in core material. But the implication is huge. If Earth core captured that much hydrogen while the planet was forming, then a large amount of the material needed for water had to be present very early. This directly challenges the simplest version of the dry Earth story. Maybe the planet was not born waiting for delivery. Maybe part of the inventory was already inside the building materials. Recent work on meteorites, similar to some of the material thought to have contributed to Earth formation, points in the same direction. For decades, material formed near the young sun was often treated as too dry to supply much water. But some of those supposedly dry meteorites contain hydrogen. Enough to make the old picture uncomfortable. The delivery truck may still have arrived. It just may not have been carrying the entire order. The oldest minerals on Earth make the timeline even stranger. Tiny zircon crystals have survived from the earliest chapters of the planet, and some are about 4.4 billion years old. Their chemistry indicates that liquid water may have interacted with the crust surprisingly early. That does not prove a peaceful blue ocean covered Earth at that time. It means liquid water may have existed when the planet was still extremely young. That creates another mystery. How did it survive what came next? Early Earth was not a quiet place. Large impacts released enormous amounts of energy, and the collision thought to have formed the moon may have melted and vaporized vast amounts of material. If water existed before or during that era, how much survived? How much escaped? How much was hidden? And how much came back later? The moon helps because Earth is terrible at keeping old evidence. Plate tectonics destroys ancient crust. Erosion removes landscapes, rocks melt and reform. Earth continually shreds old documents. The moon keeps much more of the paperwork. No weather, almost no erosion like ours, and no plate tectonic recycling comparable to Earth. Its surface is an archive of impacts stretching back billions of years. This is why the Apollo samples keep becoming more valuable instead of less. The astronauts brought them home more than half a century ago, but scientific instruments keep improving. A sample can sit in a laboratory for decades and then answer a question nobody knew how to ask when it was collected. That is exactly what makes the 2026 Apollo water results so interesting. Researchers analyzed lunar soil to better constrain the amount of meteorite material that struck the moon over time. Because Earth and Moon occupy the same neighborhood, The lunar record helps limit how much late-impact material could have arrived at Earth. The result does not erase asteroids from the water story. It says late meteorites cannot simply be given unlimited credit. That pushes us back toward earlier delivery and water already present during Earth formation. The Moon played another trick on us. For a long time, early interpretations of Apollo material helped create the image of a very dry Moon. Then instruments improved. Scientists returned to old samples and found water locked inside volcanic glass and minerals. Other missions found hydration across the lunar surface and water ice in permanently shadowed polar regions. The Moon did not suddenly become wet. Our ability to ask the question improved. The evidence had been sitting in Houston. We just needed better eyes. The Moon also shows another way water can appear: the solar wind. The sun constantly fires particles into space, including hydrogen. When that hydrogen slams into oxygen-bearing minerals on an airless body such as the Moon, chemical reactions can create hydroxyl and water. Laboratory experiments have reproduced this process under conditions designed to mimic the lunar surface. The sun, therefore, plays both sides of the water story. Solar radiation can help destroy water molecules and drive atmospheric loss. Solar wind hydrogen can also help make water on mineral grains. The same star can be arsonist and plumber. Asteroids offer another part of the puzzle, and Bennu gave the United States one of the best pieces of evidence we have ever brought home. In 2023, a capsule carrying material from asteroid Bennu slammed through the atmosphere and landed in the Utah desert. Inside was something much more valuable than a shiny space rock. The material had been collected directly from the asteroid and protected from uncontrolled exposure to Earth. That matters because ordinary meteorites hit the ground, sit in rain, touch soil, collect microbes, and become difficult to interpret. Bennu arrived with chain of custody. Then, scientists opened the evidence bag. The sample contained minerals formed through interactions with liquid water and revealed a history of salty brines inside the parent body from which Bennu came. Then came the organic chemistry. Researchers detected 14 of the 20 amino acids used by life on Earth to make proteins. They also detected all 5 nucleobases used by terrestrial life in DNA and RNA. That sounds enormous. It is enormous. It is not life. Bennu did not bring back an alien cell. It brought back a well-stocked chemical kitchen: water, salts, carbon-rich molecules, amino acids, nucleobases, ingredients that biology uses. The distinction matters because chemistry does not need biology to produce interesting molecules, and biology does not automatically appear because the pantry is full. Still, Bennu changes the emotional weight of the question. Long before Earth had forests, whales, cities, or humans, small bodies in the solar system already contained water, altered minerals, and a surprising selection of organic chemistry. The early solar system was not chemically empty, waiting for Earth to invent everything. The ingredients were being moved around. For directed panspermia enthusiasts, this looks tempting. There is the cargo, there is natural transportation, and there are ingredients associated with life. But again, there is no sender. A box of flour does not prove a baker visited your house. It proves flour exists. Comets remain in the lineup too. They are the obvious water carriers because they contain huge amounts of ice. Early in solar system history, comets struck planets, so it would be surprising if they contributed absolutely nothing to Earth water. The problem is the chemical fingerprint. Scientists compare the ratio of heavy hydrogen to normal hydrogen in comet water with the ratio in Earth oceans. If they match closely, the comet becomes a better candidate. Some comets come closer than others. Many do not match well. The famous Rosetta measurements of Comet 67P, for example, found a ratio quite different from Earth-ocean water. That weakened the clean story in which one family of comets simply filled the seas. It did not eliminate every comet. Comets are not identical. They formed under different conditions, and we have measured only a tiny sample compared with the number that existed in the young solar system. Comets can remain contributors without being the entire answer. That phrase will keep returning. A contributor is not necessarily the source, and Earth-ocean itself is not a perfect reference sample. Water has been processed for billions of years. Some evaporated, some froze, some reacted with rock, some went into the mantle, some came back through volcanism, some hydrogen escaped to space, and some hydrogen moved toward the core during planet formation. The isotope ratio we measure today is not guaranteed to be the untouched ratio of the first ocean. Our main witness spent 4.5 billion years wandering around the crime scene and touching everything, so even the fingerprint has fingerprints on it. This is why the mixed origin model becomes so attractive. Not because scientists are giving up, but because the evidence points in several directions at once. Interstellar material, water and hydrogen in the building blocks of Earth, early asteroid delivery, some comet contribution, water produced on mineral grains by solar wind, internal recycling and atmospheric loss. None of these has to be completely wrong for another to be partly right. Nature is not required to respect the structure of a documentary. There may be no final scene where one suspect confesses. There is another weird question hiding underneath all of this. How old is water? Not the atoms. The water. Imagine one molecule in the Pacific. Sunlight breaks it apart. Its hydrogen moves somewhere else. Its oxygen enters another compound. Millions of years later, those atoms meet new partners and form water again. Is that the same water? Take an old wooden chair. Burn it. The carbon enters the atmosphere. A tree absorbs some of it. Years later, someone turns the tree into a new chair. Did the first chair return? Obviously not. But some of its material did. The same problem applies to water. The exact molecule in your glass did not have to survive intact since before the sun. It may have been broken and rebuilt many times. But some of the atoms can be ancient beyond intuition, and some isotope signatures can carry information from extremely old environments. So when we say your water may be older than the sun, the careful version is stranger than the slogan. You may be drinking a newly assembled molecule made partly from material whose history began before our star existed. The cup is new. Some of the parts are ancient. Water does something else to history. It destroys it. And the United States contains one of the best examples of how badly scientists once underestimated that power. In the 1920s, geologist J. Harlan Bretz looked at eastern Washington and saw a landscape that made no sense under slow, ordinary erosion. Huge, dry channels, giant gravel bars, enormous scars carved through basalt, boulders moved far from where they belonged. Bretz proposed an enormous flood. The idea was not welcomed. Geology at the time had spent years fighting explanations that blamed every strange landscape on one giant catastrophe. Scientists had good reasons to be suspicious of another enormous flood story. But Bretz kept pointing at the landscape, and the rocks kept being annoying. Eventually, more evidence accumulated. The source became clear. Glacial Lake Missoula had been dammed by ice. The ice dam failed repeatedly. Extraordinary volumes of fresh water ripped across Idaho, Washington, and down the Columbia system. And it did not happen just once. The landscape had been hammered by multiple megafloods. Water crossed parts of the Pacific Northwest with a force capable of carving vast channels and moving enormous rocks. What had once sounded too catastrophic became standard geology. That story matters far beyond Washington state. It shows why flood myths should neither be accepted automatically nor laughed away automatically. Water really can erase worlds. After the last ice age, sea level rose enormously as continental ice melted. Coastlines moved. Areas where people once walked became seafloor. Tsunamis, river floods, collapsing natural dams, and glacial outburst floods have repeatedly destroyed human landscapes. For a community living thousands of years ago, the entire planet did not need to flood. Their entire world needed to flood. Their homes, hunting grounds, burial places, paths to other settlements, river and shoreline. Lose all of that, and the survivors do not say that a certain percentage of the regional landscape underwent hydrological reorganization. They say the world disappeared. Give that story generations to travel through families and languages, and you can get something much larger. The flood. This is where Atlantis keeps entering the conversation. Plato described a powerful island society destroyed by catastrophe. Later generations turned the story into the most famous lost civilization on Earth. Since then, almost every suspicious underwater shape has had a chance to become an Atlantean wall before a geologist reaches the site. Real drowned settlements exist. Real submerged landscapes exist. Real coastlines vanished. Archaeologists investigate them. That is not controversial. A technologically advanced global Atlantean empire has not been discovered. These statements do not cancel each other. The ocean absolutely hides human history. That does not mean every rock is a palace. Water has an almost malicious talent for doing opposite things at once. It destroys evidence and also preserves it. A coastline erodes and disappears, But organic material buried in low-oxygen sediment may survive far longer than it would in open air. A flood tears apart a settlement, then mud covers part of it and protects what remains. Water can be the criminal and the archivist in the same case. It has done the same thing to its own history. For billions of years, water has been moving, reacting, escaping, returning, entering rock, leaving rock, mixing reservoirs and changing isotope ratios. Then we arrive extremely late and ask for the original label. No wonder the answer is messy. The old myths do not make the scientific answer easier, but they show how long people have been obsessed with the substance. Stories from many cultures describe sacred springs, healing water, deadly water, primordial water, floods and oceans beneath the world. Modern alternative culture simply gives some of these instincts new vocabulary. Structured water, encoded water, water charged by intention, a hidden ocean inside Earth, ancient civilizations powered by unknown water technology, alien engineers who delivered life. Some of these ideas begin with something real and then keep walking after the evidence stops. There really is water deep inside Earth material. That does not mean there is a free ocean in the mantle. Water really does carry isotope information. That does not mean it remembers complements. Meteorites really do deliver organic chemistry. That does not prove alien engineers sent them. Catastrophic floods really happened. That does not prove every flood myth records one single global event. This distinction is where the story becomes more interesting, not less. Reality keeps producing facts that sound almost like the conspiracy theory, then turns in a different direction. There may be the equivalent of many oceans worth of hydrogen hidden in Earth core, but there is no ocean there. Bennu contained a remarkable set of ingredients used by life, but no life was found. Enceladus sprays ocean material into space, but no organism has appeared in the plume. Maven watches the consequences of Mars losing atmospheric material, but nobody drained Mars. Apollo soil is changing our understanding of water delivery more than 50 years after astronauts collected it. But the moon was not left there as a message for us. At least we have no evidence that it was. Every time the mystery seems ready to become magic, nature produces a mechanism. Then the mechanism opens another mystery. Maybe Earth did not receive most of its water late. Then how much was already here? Maybe hydrogen was present in the building blocks of Earth. Then how did it survive planet formation? Maybe enormous amounts entered the core. Then how much stayed near the surface? Maybe asteroids delivered water early. Which asteroid populations? Maybe comets added more. How much? Maybe interstellar ice supplied ancient ingredients. How much of that chemical history survived the birth of the solar system? The answer keeps refusing to become one sentence. That may be the real answer. Earth-ocean is probably not the product of one event. It is the survivor of a long sequence. Some of its ingredients existed before the sun. Some entered the growing planet. Some arrived during violent early impacts. Some arrived later. Some were created through chemical reactions on mineral surfaces. Some hydrogen disappeared into the core. Some water was carried into the mantle. Some returned. Some escaped forever. Then the surviving fraction spent more than 4 billion years moving through a planet full of rock, air, and eventually life. And life changed the water story too. Microbes altered chemistry. Plants changed the atmosphere. Animals moved water through bodies. Humans built dams, drained wetlands, pumped aquifers, and redirected rivers. The water did not merely create the environment in which life evolved. Life eventually became one of the processes moving the water. At this point, the original question almost feels too small. Where did the ocean come from? Which ocean? The first surface water? The water inherited from interstellar material? The hydrogen trapped during Earth formation? The water added by asteroids? The molecules created later? The water recycled through mantle rock? The modern ocean, after billions of years of loss and mixing? They are related questions. They are not identical. That is why every clean answer seems to break when examined closely. Comets alone are too simple. Asteroids alone are too simple. Water only from Earth interior is too simple. Late delivery is too simple. One primordial ocean preserved unchanged is too simple. Even saying the water is older than the sun is too simple unless we ask what exactly we mean by water. Perhaps the most important clue is sitting next to us in the solar system. Mars, Venus, the Moon, Europa, and Enceladus all carry different parts of the same story. Water is everywhere in different forms: frozen, hidden, lost, bound into minerals, escaping, buried below ice. The unusual thing about Earth may not be that water reached it. The unusual thing may be what happened next. Here, a huge amount stayed accessible. Not all of it, and not forever, but enough. Liquid water touched rock and atmosphere for immense periods. Continents gave it minerals. The atmosphere let it circulate. The sun supplied energy without permanently boiling the ocean away. The interior kept recycling material. Wet environments became dry. Dry environments became wet. Chemistry had time. Then something crossed the line from chemistry to biology. We do not yet know exactly how. After that, water became part of cells, blood, trees, and eventually brains capable of asking where the water came from. Now, one of those brains can stand in an American kitchen, turn a metal handle, and release a substance whose ingredients may include material older than the sun. The same water story stretches from frozen dust between stars to Apollo soil in a laboratory, from asteroid Bennu to a capsule in Utah, from the hidden ocean of Europa to Yellowstone hot springs, from ancient rivers on Mars to hydrogen escaping into space, and from enormous ice age floods in Washington to the water inside a human cell. There was probably no single delivery, no single birthplace, no single moment when somebody could point at Earth and say that now the planet has its water. The ocean was assembled, lost, rebuilt, mixed, and recycled. Part of it may have arrived from space. Part of it may have been here almost from the beginning, and a huge part of the mystery may have been hidden inside the planet the entire time. More than 50 years ago, Apollo astronauts picked up lunar dust without knowing it would one day help place limits on where Earth water came from. That is what makes this story so difficult to close. The evidence keeps getting older. The instruments keep getting newer. Every time we learn where some of the water came from, we discover another place where part of it was hiding. The water in your glass may be younger than breakfast as a particular molecule. The atoms inside it may have crossed worlds that no longer exist. Some may have moved through stars, dust, asteroids, rock, ocean, cloud, and living cells before reaching you. Water may be older than our world. It has simply mixed its biography so thoroughly that it almost seems to have known that one day we would try to interrogate it.